Good morning, children. In this video, we are going to continue the forts, chapter forts, that already we have discussed. Something about the forts, its definition, and the effects of force. Effects of force means whenever we apply force on any object, what are the effects takes place that we discussed. There are four effects, and all the four effects may take place or any one of the effect may take place. In the continuation, we will see that force is required for all the activities. While we apply the force, in that case, that force applied from any source. Suppose I pull the table, I am the source to apply the force. If I push the same table, I am the source. In that case, the source from where the force comes must interact with the object. Interact with the object means the source must either pull or push the object. For pulling and pushing, the source must interact in the sense it has to be in contact with that object. If I take a surface, horizontal surface, any object is placed, suppose we take a block is placed. In this, if I apply the force, then I have to touch the object to change its state. By applying force, the object will change its state. So, the force occurs due to interaction. Suppose you people are also experiencing in your daily life activities. Suppose you and your friends are playing some game. In that case, whenever you are going to take something, the same time your friend is also taking that same thing. In that situation, both are pulling the object towards you. You are pulling towards you, your friend is pulling towards him. So here also the force occurs. In this, the you people are interacting with each other with the help of that object. So always the force involved during interaction. Okay. So this force is applied on this object. Then we need to find what is the magnitude value of that force. How much force is to be applied to change the state of this object. The force applied should be sufficient to change its state. In that case, the force has to be measured. It has to be measured. It has to be measured. Because in physics, everything is to be measured. Here, the force is also to be measured. To measure the force, we need a unit that in last classes, class 6 also, you people have studied about a SI unit. SI unit, International System of Unit. Every quantity has SI unit. Here the force is also a quantity. It is also having some SI unit. And this force is measured by the unit Newton. It is named after a scientist who who measured the force clearly, who gave the relation to measure the force, who discussed all kinds of aspects related to the force. That's why the unit is measured after his name, that is Newton. His full name is Isaac Newton, Sir Isaac Newton. So simply we use the unit Newton. If we use simply the symbol, it should be capital letter, otherwise it is small letter. Suppose if I apply the force may be applied on this object, it may be 10 Newton. It should be written like this. It may be 100 Newton, any value. And that we say that is the magnitude of force. That is magnitude of force. Here we are measuring the force with the SI unit Newton. And in the changing the state of object, one more thing. Here I am applying only one force. Single force is applied on this object. If we apply more than one force, then what will happen? There are so many things that many forces can be applied on this object, but for our convenience, we are going to take only two forces are applied on this object. For this, again we are going to take a horizontal surface. On this, we are putting an object. On this object, we are going to apply forces. Let us take two forces are applied on this object. That two forces applied may be taken in different cases. One is, suppose I applied one force. It should be represented by F1. That is first force. F1 means first force. F and the 1 must be written in subscript. This may have any magnitude. Then the second force is also applied. The second force is applied in this manner. The second force is also applied here. Now you see that both F1 and F2 are having different magnitudes. When they are applied on the same object, and from the diagram you can say they are applied in the same direction. So while the two forces are applied in the same direction on an object, then the total force can be calculated just by taking total force acting on this object can be calculated by taking F, that is total force, is equal to the magnitudes are added, that is F1 plus F2. That is the total force acting on this object. Conclusion is, whenever two forces are applied on any object in the same direction, the total force is calculated by taking the addition of magnitude of the forces. This is what the two forces are applied in the same direction. Then coming for the two forces are applied in the opposite direction. Two forces are applied in the opposite direction. So in this way, this is an object, first force and the second force. They are applied in the opposite direction. Here we find the net force. We should say it is the net force or resultant force applied on this object. The resultant force or net force acting on this object, that is F equal to, since the two forces are acting in the opposite direction, the difference of two forces must be taken. Difference of two forces, that is F1 minus F2. Why should I write it is F1 minus F2? Because conventionally we are taking the forces which are acting towards right taken as positive. So it is acting towards right. F2 is acting towards left, that is taken as negative, just like the number line. In the number line towards right all the numbers are increasing, towards left numbers are decreasing. This is the resultant force. So F1 plus F2 minus. In this net force, finding the net force, we can have three possibilities. Three possibilities are if F1 greater than F2. So this force is greater than this force. Then what will happen? If F2 greater than F1, then what will happen? If F1 equal to F2, three possibilities are there. So whenever the greater force applied, in that case, the net force is calculated by taking the difference, and in that, along with the magnitude of force, the direction will also be produced. Means here F equal to F1 minus F2. Since F1 is greater, this is greater than this, definitely the resultant force is positive. Is positive. Positive means positive is towards right. That means the object will move towards right. In the second case, if F1 less than F2, then F2 is greater, then definitely the net force is negative. Means this is greater than this one. Smaller number minus greater number, answer is negative number. It represents, negative number represents the object move towards left. Move towards left. Then in the last case, if F1 equal to F2, in that case net force acting on this object is 0. Both the forces are equal and opposite. Applied on the same object, the net force is 0. Here you must think about it. The object is being given by two forces, F1 and F2. Forces are applied, but still the object remain in the same state. In the same state means, in the beginning, if it was at rest, remain at rest. It was in motion, it will be in motion. So that represents the resultant force acting on the object is 0. The next, further, we can continue in the next video.